Hey guys, and welcome to the real part 23, which would be a focus on rather, of dividing monomials. I'm going to write what we were doing in this part right here, dividing monomials. And this is a slightly quicker way of us dividing monomials. Now, it's recommended that you don't watch this tutorial, or you move on to part 24, which begins chapter 6, and come back to this once you've really mastered dividing monomials, like practicing a little bit, so to speak. But if you're ready to take the next step, then it's time that we begin this tutorial. Now, back when I told you the other way, it was to reduce the equation by multiplying the most we can to get this bottom as close to 0, as close to 1 as possible, rather, and then we'd have to go from there, and then we get, for example, the answer to that would be 2x times 2y is 4xy, and that makes sense. But what if I told you there's an easier way for us to do this? So let me write this equation, 4xy, and we're going to divide this by 2x. Now, when you used to do subtraction, when you used to do division a while ago, I'm going to give a little bit of a real number example, of a constant example. I told you guys a while ago, I believe, and if not, it's common knowledge that when you write a division sign, when you write a fraction bar, you're really saying a division sign. So basically, to simplify it, while we could divide 6 by both sides, an easier way to just be divide this into here, and then see that it equals 2, and 12 divided by 6 is equal to 2. So another one would be 4 divided by 2, well, that is equal to 2 again, and then 18 divided by 9, it's also equal to 2. Let me go for one that's not equal to 2. 18 divided by 6, that's not equal to 2. So we can even use this in the real life scenario, in our scenario right here. We can divide this by the numerator to get our answer in simplified terms as well. We saw that the answer this way is 2y, so let's see if we can get 2y again via this way. So we're going to take 2 and we're going to divide it by 4. So 4 divided by 2, well, that's 2. So then the 2 and the 4 have canceled out. Now I'm going to divide the x by the x. X divided by x obviously will be 1. So, I mean, while you could really say times 1 and then y would remain the same, it's really no point in including that 1, if you recall, because 2 times 1, you can already solve that. 2 times 1 is 2. So then the answer becomes 2y. And if you can make the assumption, these are the same exact thing. Let's do another one just to see if you guys can understand this a little bit more. Let's do 16x squared y cubed divided by 4xy squared. And remember, the old way would have been to just divide the denominator by the numerator, but we're going to do it our new way. So I'm going to change into red right now, and we're going to take out the 16, because 16 divided by 4, we can definitely do that. And we're going to solve to get 4. Now, we're going to divide x squared. We're going to write x squared divided by x, and remember, x would always be to the first power, so then we get regular plain old x. So these two have canceled out. And remember, another way of looking at it, subtract the numerator from the denominator, so 2 minus 1 is 1, so 4x. And then, same thing over here, y cubed minus y cubed divided by y squared, it becomes plain old y. So our answer became 4xy. And this is a slightly quicker way of doing it. As you can see, there's not so much work, and, but you really have to, just kind of discern yourself a little bit. Now, let's do a different one. Alright, here we go. This is what I wanted to get to. I'll even make this a little bit more. Alright. So our first step was to divide this by this, but we really don't want to keep our we don't want decimals when we're dealing with variables. We can have them, but fractions are equal to decimals, which equals to percent. If you remember your basic math tutorials, and either form is really acceptable. So while we could solve it out, if you're a kind of guy who likes decimals, I mean, you can write it out as, I believe that would be 8.5. You can write it out as 8.5, but if you guys like fractions, then there's really no point. You can't really do anything as far as dividing it out goes. So we're gonna have to keep this the same, and we can't divide anything else when the x's out, but we can divide the y's. So I'm gonna switch into red now, and we're gonna do y squared minus y cubed divided by y, which, as you learned, would be y squared. So we're gonna keep y squared on the top. And remember, we're going to have to carry the 17 over and the 2 because we can't divide anything else out. We're going to have to keep the x squared. And lastly, we're going to have to keep the z because z can't be anything. So that would be our simplified equation. And by the way, this is where a commutative property comes in. This is the same thing as this. 17 x squared y cubed, and we can also move it around. But for consistency, I'm going to get my final answer. I'll actually keep it in decimal form. It'd go on the top. 8.5 y squared x squared divided by z. Or another way of writing it would be 17y squared x squared divided by 2z. Now I hope you're kind of starting to understand how this this entire scenario works. So I'm gonna do a really quick just brush up of 5-1, and remember I've created my own little lesson thingies. 5-2, 5-3. Alright, so 5-1 was adding. So I'm gonna give you guys a quick equation. Oh, that was bad. Okay, anyways. That is a pretty long one. I'll have you guys solve this one while I'll go to the next one. Alright, and lastly, alright, let's solve all of these now. See if you got the same answers that I did. Alright, so these two are going to cancel out, become 6x. Are there any more? Okay, those are the only two like terms. We're going to have 6x. And, oh, we're not going to want that. Next is x squared. So negative 2x squared plus 3x squared. Negative 2 plus 3 is positive 1, so we have positive x squared. Nothing else, so I should have kept that. Okay. And lastly, we have the y's. Y squared, no other y squareds. Okay, we're going to keep y squared. And no other regular y's. So our answer becomes 6x plus x squared minus y squared plus 2y. If you got that, you're free to go. Alright, here we're going to have to multiply the constants first, and we're going to get 36. I'm going to multiply the x's. Anything that has a base of x. So x squared times x cubed. Well, we add the exponents, and it becomes x to the 5th. And then when we're doing y's, we have y squared, y cubed plus y squared. So we're going to do, we're going to have to add these. So 3 plus 2 equals 5, so y to the 5th as well. So that was pretty cool. And then g cubed, nothing happens, so we're just going to tack that on at the end, and that was our answer. That's our monomial. Now here, there's two different ways. I'm going to show you guys how to do it the new way, because this is part 23 after all. And so we should probably do it the new way. So I'm going to take off 14 and 7. I should probably do this in standard red. 14 and 7 to become 2. X squared divided by x, well, you subtract the exponents, and remember this has an imaginary exponent of 1, so x2, so 2 minus 1 is 1, so we get regular x. And then y's and y's cancel. Remember, it's just going to be times 1, but there's no point in putting times 1 because it's automatically going to go into 2, and it's going to remain the same. Remember, identity property multiplication tells us that we can ignore that step. And then we're going to have to add the z onto the end, and then we're going to put that all over g. So that was our answer. And if you can do these two types of equations, then you've really understood chapter 6, and we can move on to chapter 5 rather, and we can move on to chapter 6, which is going to deal extensively with graphing, and that's going to be obviously a lot of fun. So see you guys then.